All right, we are moving on to inequalities. So we're actually going to start with this worksheet here first. So the first thing is think about what is an inequality. Well, inequality, we have kind of here this like unequal, right? So an inequality is something that we're not going to use an equal sign with. And so instead of using an equal sign, we use signs like greater than, less than, greater than or equal to, or less than or equal to. And so we're going to kind of look at how these all work. So this first statement says you are in at least 5 of the photos. What that means is that the smallest number of photos that you are in is 5. So at least 5 means that it's going to be 5 or 6 based on this number line. Right? So what do we notice about the numbers that we circled? Well, the numbers that we circled, the numbers are greater than or equal to 5, right? Greater than or equal to 5. Are we including the number 5? Yes, we are. We are including the number 5 because we're giving that as a reference, right? It's more than 5. It's at least 5. So the smallest number it can be is 5. So what other numbers then could we include in this? Well, anything greater than 5, right? So I could have 7. I could have 12. I could have 16. I could have 286, right? Anything greater than or equal to 5 works for this inequality. Okay, my next one, the temperature is less than -4 degrees Fahrenheit. So less than -4 means that I'm going to include -5, that's less than -4, -6, and -7. Is -4 less than -4? The answer is no. -4 is not less than -4. -4 equals -4, but it's not less than, so I'm not including 4. So we just answered the second question. Can the temperature be exactly -4 degrees? No, it can't. It's not included. Because -4 is not less than -4. So the numbers that I circled are less than 4, right? Less than -4, but not equal to 4. But not -4. So some other numbers that would make this true, right? I could go -10, -15, -20, -25. That sounds miserable. I'm not looking forward to winter. But any of those numbers would make that true. Our next one. More than 3 students from our school are in the chess tournament. More than 3. So more than 3 means that it's all numbers that are greater than 3. But this is similar to our last one, right? We're not going to include 3. So they're numbers greater than 3. Greater than 3, but not 3. Right? Because is 3 greater than 3? Well, no, that's not a true statement. So that's not going to be in our solution. So our number 3, is number 3 included? No, it's not. It's not part of our solution. So 4 more numbers that make the statement true. Anything greater than 3. So I think we had 3, 4, 5, 6. So let's do like 7, 12, 23, 96. Okay, any number greater than 3 is going to satisfy that. Okay, last one. The balance in a yearbook fund is no more than -$5. So the most that it is -5. So I'm including -5 because it is the most. Oops. I want it to go back. Okay. But then it's also going to be less than that, right? It's no more than -5, which means that it's less. So the numbers that I circled are numbers less than or equal to -5. Is negative 5 included? Yes, it is. Okay, and we're going to write 4 other numbers that make the statement true. So negative 10, negative 14, negative 18, and negative 22. Right? 4 other numbers, all of them less than or equal to negative 5. Okay, we're going to stop with this worksheet for now, and then we're going to move on to some notes. So pull out this, or take out this note sheet. Pause this video if you need to in order to open it up. So we're writing and graphing inequalities. That's our focus right now. So we just had a little bit of an introduction to some inequalities, and now we're going to kind of dive into what they actually are. So the first vocabulary word here that I have is just inequality. So an inequality compares one expression to another. And I'll show you what I mean. Compares one expression to another. So for example, I could have 2 is less than 6, right? Is 2 less than 6? Yes, it is. That is comparing one expression to another. The ones that we're going to be looking at are going to be more like x is greater than negative 3, right? I'm comparing x to negative 3. X is greater than negative 3. So an inequality compares one expression to another. My solution of an inequality is a value that makes the inequality true. Okay, so it's just one number that makes the inequality true. So if I'm looking at x is greater than negative 3, right, I could have negative 1 is a solution to my inequality. 3 would be a solution. 6 would be a solution. 12 would be a solution, right? Anything greater than negative 3 is a solution of my inequality. So then my solution set is all values that make it true. All values that make the inequality true. So in my case of x is greater than negative 3, my solution set is all values greater than negative 3, right? All values greater than negative 3. Okay, so those are our vocab words, but we also have these different inequality symbols that matter. And some of the hard stuff with inequalities is that there's a lot of like words that we need to figure out the meaning of in order to get the inequality right. So we're going to go through each of these, and I'm going to give you some words that we often associate with each inequality. So this first one is just less than, right? You should recognize that. You may also hear fewer than. Okay, and then the other thing we're going to include in this is what it looks like to graph it. So if I graph an inequality, right, I do it on a number line. Let's say I've got 0 here, negative 1, negative 2, 1, 2. And let's say I have the inequality x is less than 0. Okay, so when I do that, I'm going to have either an open or a closed dot at the value that I'm talking about, and then an arrow pointing in the direction that my inequality is going. So in this case, am I going to include 0 in this if I'm saying x is less than 0? I'm not, so I'm going to put an open dot on 0. You can either do it on the number itself or directly above it on the number line. x is less than 0, which means my numbers are getting smaller and my arrow has to point to the left. Okay, so when I look at less than or fewer than, when I graph this, I'm going to graph it with an open dot. An open dot. Our next one here then is greater than. Maybe. All right, here we go. Woofda. Okay, greater than. Let's try this again. Here we go. Great. Greater than. Okay, you may also see more than. And this one is also going to be an open dot. Those are pretty straightforward. The trickier ones then are over here. So my next one is going to be less than or equal to. Less than or equal to. You may also see the words at most. And you may also see no more than. In this case, less than or equal to means that I'm including the value that I'm talking about. So this one is going to be a closed dot. Last one, greater than or equal to. You may also see at least. It's at least this. No less than. And this one is also going to be a closed dot when we graph it. Okay, so we've got some examples here. We're going to write inequalities based off of these words. So I'm going to take it one step at a time. The number x, so I know that x is going to come first. A number x is at most negative 10. At most, I see up here is in less than or equal to. So x is less than or equal to negative 10. It's at most negative 10. My next one, twice a number y, is more than negative 0.5. So I'm going to start at the beginning. Twice the number y. Well, I know to write that. It's going to be 2y. 2 times y. Is more than, it's greater than, negative 0.0, oh no, 0.5. Woofda. 2y is greater than negative 1/2. Okay, so we're going to look at here then, is this value a solution to our inequality? So I'm looking at this value of x, plugging it in to this inequality and seeing if it works out or not. So x plus 2 is less than or equal to negative 1. So I've got negative 2 in this case, plus 2. I want to know, is that, question mark, is that less than or equal to negative 1? Well, negative 2 plus 2 is 0. Is 0 less than or equal to negative 1? No.
This is Tracy.
No, 0 is not less than or equal to negative 1. It's actually greater than negative 1. So this is not a solution. No. Our next one, we would do negative 3 plus 2. I want to know, is that less than or equal to negative 1? Well, negative 3 plus 2 is negative 1. Is negative 1 less than or equal to negative 1? Yes, it is. It's equal. So that one works. It satisfies it. Last one then is negative 4. Negative 4 Ooh, come on. Plus 2, is that less than or equal to negative 1? So negative 4 plus 2 is negative 2. Is negative 2 less than or equal to negative 1? Sure is. This is a solution. All right, we just have a few ones to graph and then we will be done with this for now. So I need to graph the inequality. X is less than negative 1. So when I do my graphs, right, I just write a few numbers so that I know where I'm going and what I'm talking about. I don't need to write a whole bunch of them. Oops, it would help if I put the right number, negative 1. Okay, so I'm starting at negative 1. Am I including negative 1? I'm not. Okay, so I'm going to have an open dot here at negative 1. X is less than negative 1, so my arrow is going to be pointing to the left. X is less than negative 1. Next one, this says that Z is greater than or equal to 4. So if I've got this number line here, let's do 4, 5, 6, 3, 2. Am I including 4 in this? Yes, I am. So I'm going to do a closed dot here. Z is greater than or equal to 4, so my arrow is going to be pointing to the right. Now, someone in one of the class today pointed out to me like, hey, Mrs. Olson, the direction that the point is facing, that's the way that my arrow goes. And that is true as long as your inequality is written in this form where the variable comes before the number. So let's look, for example, at this last one here, number 4. I have negative 1/2 is less than t. Well, all of these other ones, my variable has come first. In this one, it doesn't. So in this case, I can't rely right away on which way the inequality is pointing to show me what direction the arrow goes. In elementary school, you probably learned that the alligator eats the bigger number, right? So in this case, my alligator is eating t. T is the bigger number. So if I were to rewrite this, I could write this as t. It's bigger than, so it's going to be greater than negative 1/2. Now that I flipped it around, this will work again. So I'm going to graph this. Let's see, I'm going to have, let's do 0, 1/2, oops, 1, negative 1/2, negative 1. Okay, I'm starting at negative 1/2. Am I including it? No, I'm not. So I'm going to do an open circle at negative 1/2. My arrow is pointing to the right. My arrow is going to the right. Okay, same thing up here, right? I'm going to start with 0. Ooh, hello. 0. Let's do 1.4 here. Oops, negative. This is not working for me, is it? Okay, that's just, oh, I'm almost done. 1.4, negative 1.4. All right. S is less than or equal to 1.4. So I am including it because it's or equal to. So I'm going to do a closed dot at 1.4. The point of my inequality is pointing to the left. My arrow is going to point to the left. All right. That is all that I have for us for 4.1.